right, this is going to be a tutorial on weight-based dosing calculations using dimensional analysis. All right, so our first one here is amoxicillin 400 milligrams per 5 mLs, and we need 600 milligrams PO/TID. What we need to solve for is milliliters per dose. So that's going to be how we start our problem. Milliliters per dose is what we're looking for. All right. The next step is to find somewhere in the question where you see milliliters, and I'm seeing that right there. So we have 5 milliliters, and this needs to be tied to whatever it is in the question. So in this case, it's tied to this 400 milligrams. So we're going to have to transcribe that with it. So we have 400 milligrams. All right, now we need to find something in the question to cancel out our milligrams, because really we're solving for our milliliters per dose, and those are the units that we need to end up with. So in this case, we have 600 milligrams, and that's actually the dose. So we have 600 milligrams per dose. Our milligrams are going to cancel out, which is what we want. And on the top, we have milliliters and dose. So those are our units, so we know we're in the right direction here. So 600 times 5 is going to be 3,000, and we're going to divide that by 400. If you want, you can cancel out your zeros just to make it a little more manageable. So in this case, we're going to do 30 divided by 4. That's going to be 7.5 milliliters. All right, now let's work through this next problem down here. So clindamycin, 100 milligrams per 2 mLs, 500 milligrams 4 times a day. We're solving for milliliters per dose. All right, so we need to start with milliliters. So we have to find somewhere in the problem where we see milliliters, and we can pull it from the concentration. So we have 2 milliliters, 100 milligrams. Now we need to get rid of our milligrams. So it's right here. So we can pull that in, and that's 500 milligrams per dose. Milligrams will cancel out, and we're left with milliliters per dose. So that's what we want. So we're going to have 1,000, which is the 500 times 2 divided by 100. Can cancel out our zeros. And that'll leave us with 10 milliliters per dose. All right, this next one is throwing a little bit more complexity in it. So we're going to be doing 2 different things. We're going to calculate milligrams per dose and then milliliters per dose. So our first one here, we're going to do milligrams per dose. So let's go all the way across. So we're looking for milligrams somewhere in the question, but this gets a little tricky because we see it here and here. So which one do we take? So the next thing to look at is what is going to be tying it to a dose. So this milligram is just showing the concentration of the drug, but this one is actually tied to the dose here. So this is the one that we're going to take. So we have 20 milligrams per kilo per dose. All right, so the next thing we need to do is get rid of our kilograms. We need our dose to stay here, so we're not going to do anything with that, but we need to find somewhere where we have kilograms in the question, and it's up here. So we can move that over here, and we have 30 kilograms, and you can just put that over 1. It's a whole number, so that's going to cause us to cancel out our kilograms, and we're left with milligrams per dose, which is what we want. So the top is going to be 6,000 if we multiply 20 by 30, and this will be over 1. So in this case, our dose is going to be 6,000 milligrams, which is really out there. You wouldn't actually give that much. This is all for the math, right? Okay. All right, so our next one is going to be that we need to figure out now our milliliters per dose. This is probably going to be a ginormous number too. So first thing we're looking for is milliliters somewhere in the question, so I can see that here. So we have 5 milliliters, and that is tied to our 250 milligrams. Next, we need to get rid of our milligrams. So what we can do is use what we already calculated. You could go through the whole motion of doing 20 milligrams over kilo per dose, but then you would just be repeating what you've already done up here. So what we're going to do is just use that calculation that we already did. So we have 6,000 milligrams per 1 dose. It's going to cause us to cancel out our milligrams. We're going to be left with milliliters per dose. So this will be 30,000 divided by 250. Get rid of one of our zeros just to make it a little easier. We're going to do 3,000 divided by 25, and that's going to give us 120 milliliters, which is also very unrealistic, but the person who wrote this question didn't think of that ahead of time, which is me. All right, so this next one is going to be a little bit different, but still kind of complex. We're looking for first our milligrams per dose and milliliters per dose. So I'll get a little. All right, so first thing, we're looking for something in the question that has milligrams that's tied to our dose because we're going to have two things here. So we have to figure that out. So I'm going to use the 90 milligrams per kilo per dose. And we need to get rid of our kilograms. So we have to look for kilograms, but we have pounds instead. So what we can do is convert this pounds into kilograms. So we know that 1 kilogram is 2.2 pounds. And I would recommend doing it this way so that you're not doing mental math or just plugging it in the numerator when it should be the denominator and vice versa. This just keeps everything kind of organized. So you know you're canceling everything out appropriately. So this will cause us to cancel out our pounds. We can cancel out our kilograms, and we're left with milligrams per dose, which is what we wanted. So we have 124 times 90 divided by 2.2, and that's going to give us an outrageous dose of 5,072 milligrams per dose. So again, super large dose, not realistic. Next, milliliters per dose. So we're going to solve again, kind of similar to what we did in the previous problem. We have 5 milliliters that we can use up here first, and that's tied with 600 milligrams. And then what can we use to cancel out our milligrams? Well, we already calculated it right here, so we can do 5,072 milligrams per dose. That's going to cause us to cancel out our milligrams, and we're left with milliliters per dose. That's what we want. And from here, we're going to do 5,072 times 5. And then that equals 25,363. Oops. 363 divided by 600. which is going to be a whopping 42 milliliters per dose. All right, I hope this was helpful for you.